Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have a Luxman turntable. This is a PD277. This is a client unit. He brought this to me. He's been sitting on this project for 2 years, waiting to find somebody that would take it on to do this for him. And I think he's waited long enough. He wants to have this finished. So this is going to be a short project, I think. I don't think there's anything wrong with the turntable. He just wants, let me show you here. First off, the biggest problem is the lid. Somebody tried doing some polishing, and I think they royally cocked it up. But I'm looking at this lid, and there's some really nasty scratches in it. So we'll have to, I told him I would address it. I'm not entirely happy about polishing lids. You know, like spend my time doing other things. But they even tried polishing the inside, and I can see it's got quite a haze on the inside. But there is some scratches here. The trick behind this is you have to sand out all the scratches with the appropriate sandpaper first, and then you work your way to your polishes, and then you work it up until you get it crystal clear shine on it. But this is, yeah, there's polishing residue. You can see the polishing residue here. And I've already taken the time to remove the badge so that doesn't get damaged when I polish. So I'm going to spend some time doing some polishing on this. You're not going to see it on film, but I think I'll see what I can do to make this look better. Anything I do will make it look better than what it is now. So he supplied me with a turntable with an arm on it. I don't know anything about this arm. I don't know anything about turntables and arms and stuff like that. Some people are right into it, but I'm not. But he did supply me with a few things. New cartridge, moving magnet. It's an E3 moving magnet. And let's see here. Moving magnet cartridge from the UK, made in Japan. And then he provided me with some hardware for the hinges for the lid. So I'm going to go through and do the service on this. It's direct drive. I think what I'm going to do is probably just give it a recap, just because it does look very nice. It's got a nice, huge, thick platter, and it's got a nice mat to go with it. And it has this interesting looking tone arm. Very nice. So I'm going to piece it all together and clean it up, and I'll start first with recapping it just to make sure that everything's, there's probably about what did I count? I counted about 15 or 16 caps in the power supply and motor control board, just from looking at the schematics, and that shouldn't take me long. So I'll do that. Don't know if these switches need servicing or not. If they do, we'll clean those up. Alright, so I removed the platter and the mat so I could flip it upside down on the lid. We're just going to use the lid as a stand right now. I removed 8 screws, and the bottom comes right off. This is our bottom plate. Very nicely constructed. Put this aside. Alright, cover removed. We've got lots going on under here. So we have, first of all, we got a power transformer in the back with input switching, conditioning. It's got a cap here and a resistor. I don't know what that resistor's for. It's fairly big, 3 watt, 5 watt resistor. But here's our power supply down here on this board. So we got power supply with a fuse, main filtering, and then we have something here. I don't know what this is. This could be the control board, I'm not sure. On this side here we have, looks like the motor control board, the speed adjustments. Motor here, it's mounted, motor is all mounted on the other side. This is just a plate with a bearing. speed adjustments right here, and there's a neon lamp to strobe the disc. The platter has etchings on the underside of it, and then there's a mirror configuration here so that the light bounces through the mirrors up on the disc and then back out through the little window that's visible from the other side. Back in this corner we have the all tone arm operation. We've got our cartridge wires. They should be twisted. I don't know why. But this motor here, I think this motor here does auto return. I'm not sure. And then there's a solenoid here. I'm not sure what this does either. I haven't read up on this at all. A couple limit switches. We'll have to make sure the limit switches are clean, because you start getting resistance in limit switches, then the operation doesn't work properly. But everything looks like it should be okay here. Doesn't look like there's too much to do. All Nichicon caps. I don't expect I'll find any bad ones here, but I think I just might replace them just because it's in for full. And then when you return it to the customer, it'll not be any reason for it to come back. And you know what? I might test a few of these caps here and here, and if everything's 100%, I just might leave them alone. These Nichicons, they're pretty robust. I've seen these Nichicons last, and I don't know what year this thing is. Let's see a date code in here, 93 on this one. I don't know what year this turntable is. Okay, just went through and did some testing of these caps. They're all down in value, and they really should be replaced because they are pretty tired. Yeah, they're down in value, high in ESR. So I'm going to replace all these caps. There's not that many here. Like I said, there's probably about 15 or 20. And we'll get those changed, and then we'll probably end up servicing some switches. If I'll test some of these switches as well. If they test up bad, we'll either, these ones are not serviceable because they're riveted closed. Like, I mean, you could drill out the rivet, service the switch, and then put it back together with a screw and a nut. But I don't know. It's just easier to replace these little switches here. These micro switches. They're cheap, and it's just easier to pop a new one in. But we'll see how they fare up, and then we'll clean the potentiometers and run a test on the motors, and we'll get everything done under here before we put the lid back on, flip it over. Alright, so we'll get started on caps. I'll bring you back in, show you what I find, if anything, and take it from there. Alright, so I got new caps installed on both boards. That went well. I think that was a good choice. These old caps, they were really down in value and high in ESR. Now I worked these switches as well, these micro switches. I tested some of these. These were up around several ohms contact resistance, but now when I finished with them, some of these are down to around 12 and 9 milliohms. And what I did is I just put a current from a regulated current limited power supply, put it across the contacts, and then work the contacts open and closed. And just the action of the contacts opening and closing with that current going through the switch cleans the buttons on the contacts and brings them back into service. Now, if you're doing that, you have to disconnect the wiring from the switch back to the circuitry, because you don't want to be connecting a power supply to a switch and then backfeeding voltage and current into your electronics. You'll blow things up. So you have to disconnect one of the wires and make sure that circuit's open. And I just use a regulated current limited power supply. I set the current for about 2 amps and the voltage about 2 volts. You want a low voltage, you don't want a high voltage, because in the power supply there's a capacitor and it takes a charge. And the higher that voltage, the more energy you're going to dump on the contacts when you close the contacts. You just want current. You don't want to have a big spark and bang when you close the switch. You just want to have that current that is turned on, turned off. And that's just enough to clean the contacts of any residue, oxide, and cleans them up. So I did these switches. The one underneath is a power switch. Don't need to do that because the power, when you switch this thing on and off, the power keeps that switch contact clean. And I did these two switches back here. These two limit switches. Same thing, you got to disconnect the wiring that feeds back to the circuits. Otherwise you'll blow things up. And then clean these two switches. Now I'm going to do potentiometers, and I just have to remove the nut just enough so I can swing this around, and then I can use the green juice F100 and treat these pots. Probably isn't necessary, they probably work just fine, but what I'm going to do is while I'm here I can treat them. Very small amount on the contact, the wiper, and then work it back and forth a few times. And then I can just reassemble that. So I'll do this one, and then I'm done under here. I put the bottom on and flip it over. I'm not going to do anything with the mechanicals yet. We'll see how it runs before I do any adjustments or anything here, because I just don't want to mess around with anything that doesn't need fixing. Alright, I'm going to start working on this lid. Now some of these scratches are pretty deep. I don't know if you can see these here. Let's see if I can point some of these out to you. This one here, for example, they're quite deep. Well, maybe not that deep. Can't really feel them with a fingernail. They're more like abrasions. Here's another one. Yeah, this is going to be tricky. A lot of these scratches here, this all needs to be sanded out. It shows up through the polish. What you need to do is sand out the cracks first. Remove a layer of plastic down to the point where the crack disappears. Okay, then you start doing your polishing and start building up your shine. But this one shouldn't be too bad. I'm going to start probably with about an 800 grit on some of the coarser cracks, or sorry, I keep calling them cracks, they're not cracks, scratches. I'm going to start with about an 800 grit on the more severe scratches, and then probably 1,000 on the rest of this, and just get it even and get it to the point where all these little oh, here's some. There's quite a deep one right here. It's catching my fingernail. Yeah, this one's gonna need 800 grit here just to get that out. There's a few spots. There's a few spots where there is deep ones, and then believe it or not, there's even some on the inside of the lid too. Somebody tried polishing the inside. There's a lot right here. I can feel it. Don't know what's going on inside the lid that there would be scratches. Somebody attempted polishing it. Don't know what they did or how they did it. See, here's a mark too. I don't know what that is. Can you see that? Maybe my first step should be just wash this lid really well with soap and water and then dry it, and then I can see what I'm working with. But like I said, I'm going to start with 800 on the more serious scratches, and then do 1,000, a light sanding of 1,000, and then work up 1,500, 2,000, 2,500, and then I can go up from there. I can go 5,000, I can go up to 7,000. I don't know if I bother with the 5,000, 7,000. Usually after about 2,500, I then jump to the polishes, and I start working with polishes, because polishes will take out 2,500 grit scratches from the sandpaper. So let me get started on this. I did order some polishing pads, the kind you put on your electric drill, and they probably won't get here for another 2 weeks, so I'll probably start this with the sandpapering, and then when the pads get here I'll follow it up with polishing, and then I'll bring you in and show you how it's looking. What's going on with this? This looks bent. I don't know if I did that. I hope I didn't do that. Might have to get a new rod here. straighten it out. Also forgot to mention, all my sanding I do wet sanding. Okay, you only do wet sanding on this kind of stuff. And what I use for lubricant is I use just glass cleaner and just spritz it on. Just get a layer, and then with the pan, make sure your sandpaper is clean. Wash it with running water before you start, and then make sure your surface is clean. There's no dust or grit on it, because any piece of grit or sand that ends up in this process will cause big scratches, and they'll jump right out at you. You want to make sure all your sandpaper is clean, your polishing pads are clean, your lid is clean. Everything's got to be spotless before you start. And I also, like I said, I use this as a lubricant for wet sanding, and it seems to work okay. It's cheap. You could also use dish soap, I guess. Mix up some dish soap and water, and use it in a spray bottle, and just spray on a coat, and then use that. You want to make sure it's wet, and if it dries out, spray on some more. Alright, going to take a break from polishing the lid to do some of this cartridge work. So we have a cartridge here, a new one supplied. Let's have a look at it. I haven't even looked at this yet. Okay, comes with a little Allen key. And we have about 20 different languages here. So let's open this up and see what we're dealing with. Here we go. E-Series moving magnet cartridges. Thank you for purchasing this Gold Ring E-Series cartridge. All cartridges in the range feature a dual magnet generator assembly, which makes for a more accurate stereo rendition. Featuring a spherical styly with a choice of cantilevers, the E1 and E2 models are ideal as a budget replacement for an obsolete cartridge. The E3 model, which is refined, the E3 model with its refined elliptical stylus, is a worthwhile upgrade for those wishing to squeeze even more information from the record groove. Okay, pretty straightforward. Let's look at some specs here. This is an E3. It's violet color. Okay. The E3 product code is a GL0058. It has aluminum cantilever, elliptical stylus, 0.3 times 0.7 mil stylus, and it gives you characteristics here: 20 hertz to 20 kilohertz, 1.5 dB at 1 kilohertz. That's channel balance. Channel separation is greater than 20 dB at 1 kilohertz. Sensitivity 3.5 millivolts, 1 kilohertz, and static compliance is 20 millimeters a Newton. Vertical tracking angle 20 degrees. Electrical characteristics: load resistance of 47 k ohms. So if you have an amplifier that has an adjustable input impedance, you would want to set that to 47 k ohms. Load capacitance of 100 to 200 picofarads. Same thing, if you had an amplifier with an adjustable input capacitance, you would adjust it to in that range. Internal inductance is 400 millihenries. Internal resistance is 410 ohms. Okay. Doesn't say the weight here. Playing weight. The recommended playing weight for all models is 2 grams. Refer to the manufacturer's instructions for setup procedure specific to your tone arm. Don't forget to remove the stylus guard before setting the playing weight. Do not exceed the maximum specified playing weight. To prevent damage when not in use, remember to refit the stylus guard. Now, I don't know what's in here. Pull this out. It's kind of a cubic looking thing. There's your stylus guard. So here's a look at it. The big G on the top. Our connections. And a removable stylus. Now I guess you pull it down. You hook your fingernails on these two areas here and just pull it down like that and separate the two. Okay. If you can see inside there, there's not much going on. Here's our two magnets. If you can see them. Let me see if I can get some light here. Don't want to focus, do you? There, you can maybe see the two magnets. See the stylus, or the cantilever is in the center. It's going up straight up on the screen, and directly below that there's two magnets sticking out, one on each side. And they're 90 degrees apart from each other. So we can put this back. Should just snap into place. There we go. So let's put this cover on and protect the stylus. And let's mount this thing up. Let's mount this thing up. Comes with hardware. Let's see what we got here. We've got a wrench. And we have two screws. That's all we need. I think it's 2mm. I'm not sure. What is this one? 2mm. Yeah, 2mm. I always like using these instead of the Allen keys. A little more precise control. And these are cheap. You buy these on AliExpress for $1 or $2 a piece. And if you damage the tip, you just cut the end off, because the whole shaft is fluted with the Allen. So let's see if we can get this thing together. Some wires are in the way. Let's get these wires out of the way. Now this Torm does not have a removable head shell, which is kind of, it's okay I guess, but it'd be nice to have a removable head shell. And you take the head with the cartridge off and the stylus and everything, and then you can just clean the stylus or clean anything or redo your connections. So what I'm going to need to do here is turn this around so I can see what I'm up to, and then I'll get what I'll do is I'll get the wires connected. So I'm assuming everything with the wiring is good. What I'm going to do is I'm going to take an ohm meter and I'm going to check these the color codes to make sure, because white should be your hot left, blue should be your ground for left, red should be your hot for right, and green should be your ground for right. So I'm going to take an ohm meter and check the continuity on these before I continue. I'll be right back. Okay, they're all good. And they're in the correct order, so I'm going to put them on the pins. I'm just retensioning these fingers as just squeezing them together because they're a little bit loose, so I'm just going to retension them and then slide them on. But for the most part, it's this one here. This one here probably is okay. Is a little too short, the white one. So I'm going to see if I can just route this one over top of the others and then come out the top. There we go. It's not pretty. Look at this. See this? Spread the fingers, so I have to. Very gingerly do that. Okay, that's what it's going to look like. Now the next step is just setting this thing up. A lot of adjustment range here. I'll just set it close to where the previous cartridge was and just snug it. And then when I get the platter in place, I can get my gauge out and we can do that. Just going through this a little bit more in detail. Stylus replacement. Gold ring styli are manufactured to the highest possible standard. However, it is vital that the condition of the stylus is regularly checked. If properly cared for, a spherical diamond can last up to 500 hours before wear causes noticeable degradation of performance. In the case of an elliptical diamond stylus, the expected lifespan can be extended up to 1,000 hours. A damaged or worn stylus can cause irreparable damage to your precious vinyl collection and should be replaced immediately. So, yes, if you have your diamond stylus is spherical or elliptical, if it's damaged and there's a chip out of one corner, or for whatever reason, you know, the stylus is damaged, what it can do is it can scratch your record, and it can actually deform the groove and what it's riding in. So that's what they're talking about. If you have a damaged stylus, it's going to wreck your vinyl. Now, 500 to 1,000 hours, you can figure, play one side of a record, it's 20 minutes. Both sides of a record, 40 minutes. So you probably get about 1,200 albums out of a stylus, listening both sides. Maybe 1,500, because you don't always play both sides of an album. You play one side, maybe the side your favorite, and then the other you don't care for. But yeah, 1,000 hours. I don't know how you keep track of that. It's just something you're going to have to understand and live with. So here's what it looks like at the moment. I skipped a lot of steps here. I'll tell you what I did. There was some heavy scratching in some areas, so what I did is I went over those areas with 800 grit, wet sanded those areas, and tried to get those scratches down to nothing. And then I did the whole thing with 1,000. Did it again with 1,500. I think I might have done it twice with 1,500 wet sanded. And then I went to, I think the last one I ended up on was 2,500. I did a wet sanding, and you can see it's got quite a haze to it, and it's pretty. You got to understand, this is really goes against your instincts of to take sandpaper to your turntable lid, but trust me, it takes out all the little fine scuffs and scratches, and what it does is it leaves a level playing field that you can polish. And then once, I think what I might do is one more sanding of 2,500 on this, just to even it out, because there is some streaking here, I can see it, and I'll just really lightly give it a sanding of 2,500, just to remove some of the scratches from the coarser sandpapers, and then we'll move the polishes. And yeah, this is coming along. Actually, I'm just going to concentrate on the top right now. And then once I get the top polished, I'll be able to see how badly the inside is scratched, because you can't really tell right now with, there is some stuff going on here. I don't know if you can see that. There's some scratching going on there, and a scratch here. So once the top is polished, then the, oops, that should be locked in. Why isn't that locked in? The once the top is polished, then all the other scratches suddenly appear, and you can see them. All right, there's an update on the polishing. This isn't looking very good yet. This is still a work in progress. But I discovered one thing that's kind of concerning here. I don't know if you can see it. I'm going to try and see if you can get to see these lines. There's a line, let's see if I can get this the right angle here. A line that runs, if I show it from this side, from the inside looking out, you can see it quite clearly. Maybe I need a better background. You go over here, you can see this, especially on this side here. It's quite noticeable. There's some swirl marks. It looks like somebody was sanding with a machine and did some swirls, but these are actually imperfections in the molding of the plastic, and these will never polish out because they're embedded in the plastic. Oh, it's just something you're gonna have to live with. They came from either they had a dirty mold or the injection process when they did the lid. There was some contamination in there. You can see it all on this side. It's all pretty noticeable. But this is probably about 80% right now. I still have some polishing to do. I've done one polish on the top surface, then one polish on the inside surface, and I'm still seeing a lot of swirls. And if you look in the light, you can see the haze. So yeah, this has got to come a long way yet. So, but it's actually looking a lot better than what it did. I removed all the scratches on the top surface, and I removed a few of the scratches that were on the inside surface. I just need to keep going and keep polishing. Alright, plugged in. I'm going to do a first power on test. Our watt meter here, you can't really see it very well, but I'll let me adjust the camera so you can see that in the background there. And let's turn this thing on. Let's go 33. Don't know, I think. There we go, yeah. So let's put this up. And let's see how, which one's 33? 30, I'm on 33, the 33 is on the right here. So let's adjust this until we get a lock. And that one's stable. Okay, let's check 45. Adjust this one. Everything's good. Adjustments are locking within range. Let me show you the strobe here. I'll reset the camera. Okay, I hope you can see this. This is going to be 33. And I didn't quite adjust it good enough. Let's give it a little tweak. Too much. Okay, switching to 45. So it's looking good. Everything's good. We're doing 60 hertz. 60 hertz. 45 is on top, 33 is on the bottom. So yeah, that's 30. That's correct. And these two here, the two top ones, you can't see the top one, but that's for 50 hertz. There's a neon bulb in there. I did some cleaning of the mirrors to make it a little more visible and a little clearer, less foggy. So that's doing good. And I forgot to mention it's going to consume 5.5 watts when it's running, which is very nice. It's low power. It's 33. There's not much difference between the speeds. Slight increase in power consumption on the 45, but then that's to be expected. So the owner of this turntable actually provided me with one of these alignment mirrors, probably knowing that I would need it in the future. So let's just roughly check this, and you can see that the cartridge is way out of whack on both mirrors right now. I'm gonna go and do some aligning here. Actually got the cover on, so we're okay for the stylus protection. But yeah, I'll go through and back and forth this. I can't do it with the camera here because I have to get my head here and look where the camera is viewing, and So I'll align this and then I'll bring you back in and I'll show you what it looks like. Alright, I've shown this on other videos before on setting up turntable cartridges, but I'll do it once more. I did it roughly with the cover on, and if I check it now, if I put it here, the stylus is right about there. If I look down straight from the top, looking down, the cartridge is straight with the grid. That's what we want. And then if you move it over to the inside grid, the next check, and you look down, cartridge is straight. So what you're doing is you're setting the tracking angle to 2 points on the disc, and you'll never get it perfect because as the tone arm swings, it's creating an arc, right? It's creating an arc along its path, and you want to get it on these 2 points. These are the average points in the midpoints, let's say, because your groove starts here and ends somewhere here. So these 2 points are kind of a good compromise. So let's remove the cover, and we'll do this with the stylus on the mark where it's supposed to be. And if I look down, okay, it's very slightly turned this way. Okay, so I might do some fine adjustments. Let's do it on this one too. Where is it? It's hard to see. Let's see that one. And this one is a little bit this way. So I might have to, for both of these, let me check this one more time. Yeah, very slightly. I gotta rotate that cartridge. So let me loosen. And we'll just bring it just the slightest amount. And we'll check it one more time here. Got the power off too because I don't want the turntable spinning up by accident. Okay. Check that one more time. That is perfect. And check this one more time. Where are we? There we go. That's perfect as well. Alright, so we got it. It's dialed in. So let's see here. You can torque these down, tighten them up. You don't want your cartridge sliding around. Okay. I'll put the cover back on. That's done. So what you're doing is you're setting the angle with this first one. You're setting the cartridge angle, and then when you move over to here, you want the angle to stay the same. But to adjust this one, you slide the cartridge backwards and forwards in the slots. So there's two adjustments. One is your angle, one's your overhang. And when they're both correct, your cartridge will line up with the grid on both of these landing zones. That's the idea anyway. And you don't need to get a fancy thing like this with the mirror and everything. You can go online and you can download alignment guide and print it off on your printer, and it'll work just as well, because it's just two measurements, 120.9 millimeters from center and 66.04 millimeters from center, and these two measurements, and then you have your grid, and Bob's your uncle. Alright, setting up the weight, tracking weight. So first step is just set this to 0, and it's right on the line here. I don't know if you can't see it from where you are, but trust me, it's on 0. And then we'll see our tone arm should be floating, and it is. And now we need to measure. Let's see here, I'll show you. Put this away. We need to measure the album height from the base. Okay, so with the record in place, I'm just going to measure the height from the from the surface of the record to the base, so we can get a baseline reading here. And you're probably wondering, why am I doing this? Okay, so just take from this and then right there. So that's our base. We need to know how high the stylus needs to be from the Okay, so if I release this, now you're probably wondering, why did I measure that? Because the free floating height of this stylus needs to be the same. If we add weight here, its 0 point will be down here, which isn't correct. Up here is where it needs to be. So let's get this free floating, and then we have our marker here. So actually the stylus is probably about 6 millimeters too high, right? Which means to tell me that we need to move the weight this way. So let's first rotate the weight to the first. Let's give it 1/10 of a gram according to the marks. And let's measure this again. Okay, so we're right on. 1/10 of a gram, it was out. So if we go back here, let's put this on here. If we go and move this back to 0, we need to slide the weight forward towards me just a fraction of an inch. Let's see, how do we loosen this? Maybe a screwdriver. It's quite tight. There we go. Yeah, we need to slide this weight forward a little bit just to... That's probably too much. Let's see, this is set for 0. Let's see how far out we are. I think I moved it too far actually, but yeah, it's way too far. It's actually too... This is going to be tricky. Okay, we're too high. Tap it back. And what I'm doing is I'm zeroing the tone arm with this cartridge, and I'm also calibrating the 0 mark on the tone arm at the same time. That's what I'm doing. Still too high. We need to get this weight to move. Just giving it little taps. Getting closer. I'll bring you back in when it's set. Okay, so we got that set. It is now 0 at the same height as the album. And this is set for 0. And the weight is in the right position. So all we need to do now is tighten down that set screw and everything will be zeroed. We do this without moving anything. Might be a bit of a challenge to try here. Okay, I think I got it. We'll confirm. The factory setting of that zeroing was a little bit out, is about 1/10 of a gram out, and this is perfect right now. Alright, so that's at 0. This is perfect. and this should be tightened down. So I'll tighten that, make sure it doesn't move. Okay. So now that it's all zeroed, all we need to do is rotate this 1.5, 2 grams, and then we should be set for 2 grams. That's all there is to it. Alright, just to confirm, I'll get a scale out here and we'll just check this. And I've tested the scale, it's pretty accurate. And we're about 3% out. It's actually pretty good. You can adjust it a little bit on the back if you want to lighten it up. I would probably run it lighter. I might even, if it was me, I would probably even run it at 1.75 grams just to extend the stylus life that little bit. Now this is the confusing part, because I was reading in the manual and it really doesn't explain it very well. It says if you put the weight to the root, which is I'm assuming here, that's for 0.5 grams anti-skating, and then each tick is 0.5 gram. So if I count up, let's see here, but this it's really not marked very well. So is that 1 gram? Gram and a half? 2 grams? That's what I'm assuming. I think that's what it is. I'm gonna tighten this down. Let me turn the screw so you can't see it. Turn it sideways. That way it doesn't show up. Let me see here. Just want to snug this down so this doesn't slide. There we go. Alright, so we're anti-skating. I think it's set for 2 grams. If I'm wrong, somebody yell at the screen. But that seems to be working. Okay, I think we're ready to spin a record. Sounds good. I like this cartridge. It's got some nice bass to it. It's a nice bass response. So, this pretty much wraps up everything with fixing this. I'm still buffing out the lid. I kind of want to have it finished for the end of this video, but I don't think it's going to be finished. So I'm just going to continue working on that off camera. I just want to finish this one up so I can get this video out this week. And so yeah, this is a very nice turntable. I wish I had something this nice. And I'm sure that my client will enjoy it. I just still need to test out a few things. It says auto start here. And I don't know if it's even working. I'll put this to auto. Yeah, I don't know. I'll try the rear. Ooh. That was terrible. Let's see if this thing. Yeah, it's not working. Cut. Might have an electrical problem. I'm wondering if we have a bad switch. Seems like we still have a repair on this. we might not have a functioning turntable. That's what I'm thinking. Yeah, that motor that's in there, I can't hear that motor running. That motor should advance the tone arm, but it's not. I can hear a bit of the relay. Okay, so let me investigate that. Alright, so according to the service manual, what I did is I connected, there's 4 pins here, 9 through 12, and you connect a voltmeter between pin 9 and pin 10, and then you adjust VR1, okay, and then you connect your voltmeter between pin 9 and pin 12 and adjust VR2, and this is set up some voltages that are in the service manual. This one here is 0.2 volts, this one is 0.5 volts. So you set those up. This one was quite a far out. This one wasn't too bad. But now that I connect the motor, you can see the motor starting to work. So I'm going to just shut everything off here, connect this motor back up, and flip it over and see if it works now. Just trying to figure out why this motor is not working. The motor works. If I put it into, let's see here, let's put it into, turn the power on. You see the motor spinning. But it's very low torque. Well, not too bad. I thought maybe it was sticky grease, that's why I was taking it apart and cleaning it. Shut this off. But I'm going to reassemble it with some fresh grease and we'll see if it works. It sometimes works, sometimes doesn't work. It's very, very touchy. But when I flip it upside down and have the bottom off, it works. But when I put the bottom on and flip it right side up, it doesn't want to work. This is my problem. And it's frustrating to work on because you have to remove the bottom, put the bottom back on every time I want to test it. This is kind of a unique rubber. It's very flexible, soft plastic. And it seems like this is working now. I'm going to lubricate this better and put it back together. Okay, hopefully this is the last test. So when I plugged it in, turned it on, I could hear the motor running. So let's hit the start button. You can hear the motor. Tone arm's not advancing. Yeah, here it goes. Okay, the cueing's up. Now we are quite a ways off. We're about half an inch off from the edge of the record here, so we're going to have to make some adjustments. Which is good. This is just a good start. At least it's working now. So let's advance this to the end of the album. It should be picking up, and it's not. There's a photo sensor in there too. That's okay. Let's hit the cut button. It doesn't seem to have any power to go back. Try that again. Yeah, it's trying, but it's not. Ooh. Okay, I'm going to keep playing with this. I think it's just a matter of adjusting it, maybe some more cleaning. The grease helped. Got that motor going. I think the more you use it, the more it'll free up. Oh, there, it's cracked. Alright, let's try cut. Yeah, starting to work. probably hasn't been used in 20 years. That's why all that grease in there was really sticky. So I'm going to keep playing with it, make some adjustments, and then we'll wrap this up. Alright, running into troubles. I've been testing it here a few times, and it now it won't work. I think that motor is just doesn't have enough startup torque to overcome that sticky grease. I don't know. Plus another thing is, see, you can hear it working. Another thing is when it hits the end of the album. Let me try this again here. Turn this off. Turn this on. We're not getting any triggering of the end of record. There's an opto coupler in there that has a infrared LED and a photodiode, and it's when the shutter gets far enough and it blocks that light going through that coupler, it should trigger the circuit, but the circuit's not getting triggered because I'm not hearing anything whatsoever from that. If I hit cut, it should be working, but it's not. So still have to dig into it some more. Okay, I think I found the problem here. So this voltmeter is across between ground and the motor lead, which is the white one. Now it's in a rest state right now. The power's turned on and we got 5 volts. And I'm going to interrupt the opto isolator or the coupler and watch what happens when I interrupt it with the beam of light. Notice the voltage dropped, which means current is going through the motor, but the motor's not turning. And if I help the motor, see, I was waiting too long, I think. Now I can't get it to reproduce it. My point is, I think I have a flat spot on the motor. See, there it goes. Let's try the other. Let me get this. Okay, that's the motor. That's the voltage across the motor. Let's see if we have. You get a little spurt of voltage there, and there we got 3.5 volts, and the motor is not spinning. See if I can get that to go again. Seems I have a dead spot on that motor. So what I'm going to do is I'm going to take that motor apart and I'm going to check the commutators and the brushes and stuff just to make sure that it is working the way it should. I have a feeling that motor is kaput. I might have to substitute another motor. Okay, so how do you confirm if you have a bad motor? Well, just get an ohmmeter out. An old analog one. I'm going to see. Can you guys see this? Okay. It's awfully glary. So we just connect up a voltmeter, or sorry, ohm meter. Let's zero it first. I'm really having troubles with coordination today. Maybe it's something to do with the water. Alright, so that's zeroed out. Okay, that's working. Connect it up to the leads of the motor. And this will give us a visual on. Look at already it's starting to, the resistance is changing just from me moving the motor around. So if I slowly rotate the motor, you'll see we have dead spots. Yeah. So that tells me that the brushes and commutator need to be cleaned. This is a Fujaya 5-volt motor. So typically these motors are 12 volts. 5 volts is kind of unusual. One thing I'm going to do is I'm going to put 5 volts on this motor and just let it spin for about an hour. And that might just clean it up without me even opening it. And I'll just give it some time to, because you know, if the motor is sitting in one position for so long, it can develop these flat spots and dead spots. So I'm just going to connect 5 volts, let this spin for about an hour, and then we'll come back and we'll test it again. There's the current is drawing 23 milliamps, 22 milliamps, but then it shoots up. You see how it twitches from 21 to 23? It doesn't seem like it's consistent. And the motor's noisy too, so this is telling me there's something going on inside that motor that's not quite right. You can see it's twitching. I don't know if you can hear it. I'll put the thing up to the microphone here. It seems to be struggling. Okay, here we are an hour later. It's been close to an hour. I haven't been really paying attention, but I went and had lunch, and the motor seems to have really settled out, and it's not jumping around as bad as it was. You still see it's twitching a little bit, but the sound of it sounds steady, and it's not all twitchy like it was before. So, do we fix it? I think we did. Load the motor down a bit. It's got fairly good torque. That's stall right there. Yeah, I think the motor's fine. I'll put it back in. Okay, update time. So I put the motor back in. The motor is working good now. The motor's not the problem. The problem is something else, and I think I know what it is. I think there's like a, what do they call a stern nipple. There is a rubber piece that rides on a plate on the bottom of the tone arm swivel, and that is the thing that there's a rubber knob on the end there, and when the time comes, it's supposed to rise up, touch the plate, and then move the plate over to the position that tone arm should be in, and that is slipping. So here, I'll do an automatic start, and we'll see if we have any success here. You hear the motor, and there's no tone arm movement. Okay, motor stopped. So it assumed the tone arm was in position and the motor stopped, but that's not what is proper. So let's move the tone arm into position, pretend we're playing. Okay, and hit cut. Hear the motor. See, the tone arm tries to move back, but it doesn't have the ability, or the grip isn't there with that turntable. And I can hit cut again, and it just doesn't have the power to move. So I need to do something with that. Either bend the arm so that there's more clearance, more contact, or replace the I don't even know how to pronounce it, stern nipple, which I don't have. Let's try the at the end of the record auto stop. Now that wasn't working before, so if we advance the tone arm towards the end of the record, there should be a point where I hear it click in. right there. Hear the motor returning. Okay, just about there. I got some adjustments to make, and we need to increase the grip on that rubber and get this tone arm to move where it should be. All right. Okay, here's a look at the mechanism, and this is the arm I'm talking about. This is the stern dimple thing on the end here. You can't see it. Yeah, I'll remove the arm and I'll show you. We'll just take the arm out. Get rid of this. I can bend this over. There we go. All right. Now, this is the arm I was talking about, and it has a little rubber bumper on the end, and that's what rises up, grabs this disc, and then rotates it one way or the other. This way it would swing in this way, so it would rotate it this way. And this arm with this post here follows this track that's in this cam gear. This cam gear has a profile on it of both elevation and side-to-side displacement. So as this gear rotates, it pushes this arm up to make contact with the disc, and then once it makes contact, it starts rotating. The arm starts moving this way, and it moves the thing around. Now, problem is, the arm is straight right now, but it doesn't seem like we have enough grip. So what I was proposing and doing is just shaping this arm up a little bit. Just give it like maybe 1/2 millimeter on the tip here of extra height, just so that it makes that contact that much better. And I think, let me see here. Everything's so greasy. Another thing is, you got to, I already got grease on it. You don't want to make sure that this tip doesn't have any grease on it. Clean that and clean this disc as well, because any slippage there is not going to move your tone arm. Now, the other important thing is you don't want this dragging when it's not intended to, because what it will do is it'll drag on your tone arm and it'll create a tracking error. This rubber looks like it's intact and it's good condition. I think, and this is some kind of spring steel. I don't think bending it is an option. Can give it a little bit. It's not really responding. Okay, let me try reassembly this. The magic sauce here is getting this distance correct. This here. If you have too much clearance, it's not going to make good contact. If you have too little clearance, it's going to drag. So what we want to do is we want to set this up so that it's optimized for what it needs to do. So let me put this back together, and we'll we can check and see. See, we got quite a bit of clearance there. It's about, well, it's about 1.5 millimeters. So I think we'll give that a try and we'll see how it works. Alright, I think I got it. Gave it a very slight bend right in this area with a pair of pliers, and I think I have, let's see if I lift up on it. You can see there's still clearance. It's less than a millimeter, and it's a lot closer. And that should work now. This lever here, this little post here, rides on this on the bottom of this gear, this cam profile, and this is your cueing mechanism. I don't know if you can see that, the wire's in the way. This is your queuing mechanism, and this is what controls it, this cam profile right here. This cam profile here is a track that controls the arm swing, and yeah, so it should work. It should work now. Let's flip it over and give it a test. Alright, confident it's going to work this time. So confident I put all the screws back in. So let's test it. Start. Wow, it only goes halfway, huh? It wants to play hardball. Let's try that again. Yeah, it seems to... I wonder if that plate is dirty. I did clean it. Seems to be getting better with... I might have had some grease on the rubber nipple. Yeah, it's getting better as it goes. Let's keep trying it. Yeah, went all the way. It's dropping on the album. Okay. Let's check the auto return. That's working perfect. Okay, seems to be going. Yeah, I think whatever was on the surface of that rubber nipple there is cleaned off now. So, I'm going to leave this, and of course if we try cut, it should return and shut off. Perfect. Okay, so this is all back together. I got the lid finished. I did some polishing today, and it's not perfect, but it looks a lot better than what it did. And needs a good cleaning now that I finished. But here it is. It probably won't look good under the lights. Let's see if we can get this to hook in. How does this work? Okay, got that side. There. Yeah. It's a lot better. I think I need to do some cleaning on the inside. It still has a haze to it. That'll only come out with power polishing, and I could probably give it some more passes. But we do have all these imperfections in the injection molding. You can see them on the sides mostly. Here's a little bit here. You can see a big one here. Doesn't matter how long you're going to polish it, it's not going to come out. Here's another one. It's not going to come out, but this looks a lot better than what it is. What it was when it came in. Now I just need to put the Luxman badge back on. It was held on with double-sided sticky tape. So I'll clean this off. I'll clean this tape off, and we'll get some fresh stuff on there, and we'll put the badge back. And then this will be it. There she goes. It's in. Got a smudge on it. There's also a little crack here, so if you put weight on this lid, it can continue cracking, so I'd be very careful with this. But there we go. Looking a lot better than when it came in. We have fingerprints everywhere. Just give it a little buff. It's ready to go. Alright, so this is what we put into it. Just a small amount of caps. These are pretty tired. These are, what are these? These Nichicon. Yeah, they were all pretty tired, so they got replaced, and it's a good thing. This will last many more years now. Okay. Alright, there it is. Thanks for watching. And we're going to wrap this up. So take care, and we'll see you on the next one.